Hey guys, can everyone hear me? Yes. Perfect. So thanks for sticking in. I hope you guys have been enjoying the conference so far. So today, my name is Ben Ellerby. I'm the VP of Engineering for Theodo. And today I want to talk about security with AWS Lambda and how to keep our serverless applications secure. As I mentioned, I work for Theodo. We're a company that helps other companies launch digital products, from startups launching their initial minimum viable products to large companies trying to achieve a digital transformation. And more at Theodo we're using serverless. And my role in Theodo is to coach our developers and our clients' developers on how to use serverless to achieve a good architecture. Before we jump in, I guess most of you here have a working definition of serverless in your head. I don't want to start a debate about what is serverless and what's not serverless, but I just want to make sure we're talking about the same thing. So for me, serverless is an architectural movement. It's a move for developers sending application code, which is run by their cloud provider, with the details about the scaling and the patching of the operating system all abstracted away. It's also the leveraging of third parties to try and do common application logic that's not specific to your business. There's no real value in building your own user authentication, password reset, and MFA service when you can use that by a third-party provider like Cognito or Okta outside of AWS. And finally, it's things that don't cost you anything when they're not used. There's also a framework with the same name, the serverless framework, which can make a bit of confusion when we're talking about this. But today, we're mainly going to be talking about serverless, and in particular, Lambda. So why do people adopt a serverless architecture? Well, there's a cost reduction, depending on how it's used. There's a reduction in, it's not really a move to NoOps, it's more of a move to DevOps, with developers being empowered to manage their own infrastructure. Developers can focus more on delivering business value. As I touched on earlier, we're not having to deal with those low-level details of how we deploy our code, and also we're leveraging third parties for that common application logic that's not unique to our business. Finally, it's scalable from day one, and a more nuanced point is that we can build greener architectures. The internet at the minute produces the same amount of CO2 as the aviation industry, and it's only growing. And a move to a serverless architecture allows us to make more efficient usage of the resources we have in our data centers, helping us to reduce the CO2 consumption. One other thing to touch on, serverless is not just functions as a service. You might have heard that a couple of times today. It's quite a common meme in the serverless community. But Lambda, which is functions as a service in AWS, is the compute part of an application. But there are many other parts that an architecture needs. S3 for storage in AWS, DynamoDB for database, API gateway for your API management, Cognito for authentication, SQS for queues, EventBridge for an event bus, step functions. There are many, many different services that are serverless and are part of a serverless application. This provides a great amount of power and flexibility and allows us to build very powerful event-driven architectures. But today we are just going to focus on Lambda when we're talking about security. And we are going to be focusing on AWS, but many of these lessons are common across cloud providers. So we're going to go through a number of checkpoints to keeping our Lambda secure. The first one being the temp directory. So the temp directory is the only place in a Lambda function where you can write to disk. This can be quite useful to some performance optimization and very useful if you're doing something like generating PDFs. The problem is, the potential security risk is when you have a Lambda function that's invoked warm. So you can invoke a Lambda function cold. It's the first time it's been invoked. It sort of needs to be set up by AWS. When you have a warm invocation, so you hit it before it's sort of moved outside of that containerization cache, this allows the next piece of executing code to have access to the same directory. So if you've written, let's say, a PDF generator for financial data, the first invocation writes a PDF to that temp directory. The second invocation, if it happens quick enough, could have access to that same temp directory and that same PDF. So either our code, by mistake of programming logic, or injected code in a malicious way, could have access to data that it shouldn't have access to. So the first lesson here is to clean up after yourself. Whenever you write something to the temp directory, explicitly remove it. There's a sort of brute force way you can do this, where you have a remove folder recursively that you call at the end of your Lambda function. Make sure you call it on the right folder and not locally, otherwise you'll be very sad. But another way people have done this is to sort of build their own SDK for writing files with a callback function that will automatically clean up after themselves. The message here is really to train your team on this as a potential risk, and then make sure that we're cleaning up after ourselves when we're writing to disk, unless we're doing it specifically for optimization and we've considered the security risks. The next one is more of an architectural question. It's about separating our Lambda functions. There's a big debate about whether you should have one monolithic Lambda function doing everything, or many sort of micro Lambda functions doing separate things. This is potentially sort of an architectural question, but it also links very much into security. IAM, which is sort of the role management and permission management in AWS allows us to have very fine-grained permissions and roles for our Lambda functions. But if we take two contrasting architectures, we have one with sort of one large monolithic Lambda function, maybe using a traditional framework like Flask in Python, routing multiple different URL endpoints. This has all the application code deployed on one Lambda function. This has an impact to cold start times, but also from a security consideration, it has a risk. For instance, if one of these Lambda functions in this sort of micro Lambda architecture is calling Stripe, for instance, as a payment provider, and needs to have access to some super secure secret that's managed by the cloud provider, you can give it through IAM the rights to have access to that secure token or to that secure database. Whereas in the monolithic Lambda function approach, you have to give all routes to your API access to that secure token. And it goes past secure tokens, it goes to databases and access to different things. So by having a fine-grained Lambda function with a separation for each endpoint, it allows you to really sandbox the permissions your Lambda functions have to prevent your own code from making mistakes and also malicious code from having access to things they don't need access to. The lesson here is to keep your Lambdas fine-grained with a clear separation of concerns. Use specific IAM roles and policies for each Lambda function. Don't share one across all of them. And make sure you sort of have that notion of least privilege as you split them up. As I touched on a second ago, least privilege is a fairly classic security mindset of giving something the least permissions it needs to achieve the job it wants to do. IAM is a great tool for securing your application, but it's also quite a complex tool. Developers have been massively empowered by serverless to spin up into production code extremely quickly without a need for a dedicated ops team. The risk here is that maybe this comes at the cost of security. We need to make sure that we're using the right policies and roles that give least privilege. But many of us fall into the trap of using wildcard characters because maybe we've not had the proper training or time to learn those services and there aren't safeguards in place. There are a few safeguard solutions that you can automate as well as training your team. So the serverless framework, which is a great infrastructure as code tool for managing serverless applications, has an enterprise version, which is a paid version. This comes with things like dashboard, but also something called safeguards. Now, safeguards can run on your CI pipeline. And for instance, here we're getting a failed check, which is saying no wild IAM role statements. Here, someone's tried to deploy a serverless application with a wildcard statement in the IAM policy, and instantly the CI is stopping that from happening, helping the developer to learn what went wrong and preventing that mistake in production. Another tool you can use is AWS Least Privilege. So this tool uses CloudWatch and X-ray logs and analyzes retrospectively the things your application has access to, allowing you to create an IAM policy with least privilege. For instance, if you had a Lambda function that has star access to S3 and never uses S3, maybe you can reconsider giving it that access. Now, this tool is more retrospective, so it's quite good for auditing and then training your team on things that have gone wrong. And a combination of blocking people from making mistakes and auditing things that have happened in the past is sort of the key way to ensure we help our developers to be empowered and not put ourselves at risk. So ensuring that all IAM policies allow least privilege and making sure they only perform the things that making sure they only have the things they need to perform a specific task. We need to train our team on this principle. We also need to automate as many of these checks as possible. API Gateway is the sort of API management in AWS and is a very powerful tool for sort of linking our Lambda functions to the internet. One key lesson here is that not every Lambda function needs to be on the internet. If you have a Lambda function doing some sort of data migration that's only used by developers, keep that off the internet. You don't need HTTP. First of all, you're going to be limited by API Gateway's 30-second timeouts, but also you're opening yourself up to an attack vector. The AWS SDK with IAM can be a very locked down way of accessing Lambda functions, so only expose Lambda functions that need to be public over API Gateway and keep the other ones private. API Gateway also allows you to have some denial of service protection by integrating a web application firewall. This will do things like rate limiting and basic denial of service prevention. It won't handle distributed denial of service, but it will catch common things like SQL injection and a number of different security vulnerabilities. And this now fits very cleanly into API Gateway. Yan Jui, who's an amazing AWS serverless hero, produces loads of content, wrote a very interesting article at the end of last year on API Gateway and its security risks. I'd suggest when you use API Gateway, apply a WAF, but if you really want to jump deep into the details of that throttling, check out that article. It's an extremely in-depth analysis. The key thing here is to avoid exposing Lambda functions to the public internet. And when you do expose them through API Gateway with a web application firewall. Another classic security checkpoint, but particularly different for serverless applications, is observability. Basically, know what's going on. So CloudWatch and X-Ray are tools for logging and tracing in AWS and are extremely good, but probably the minimum thing you need. They provide you the data, but I would suggest leveraging a third-party serverless observability provider to give you the full insights into your application. Lumigo, Epsagon, and Thundra, and many of those companies are here today, all provide a good UI UX about digging into those traces and digging into the alerting, and really help build on top of CloudWatch and X-Ray. At the end of last year, AWS at re:Invent announced Service Lens, which is trying to tackle the same problem, but I would still recommend leveraging a specific third party for serverless application observability. As I touched on, its basic logging is a given, and we add on to that X-Ray and then a specialized serverless logging provider. The other thing here is to build your applications to be recoverable from your logs. We no longer have one request coming in and hitting a server, and our application logs can tell us quite a lot. We have a request coming in, maybe through API gateway, going into a Lambda function, into a step function, into SQS, into Event Bridge, and finally a Lambda function breaks all the way over here. Now, from a recoverability point of view, we need to make sure we build our applications with logging in mind, but also from an auditing point of view, we need to be able to understand why that Lambda function executed and why it executed with the information it did. Security has changed a lot with Lambda. You don't have to deal with operating system patching, but a lot of things haven't changed. So keeping your team up to date with the OWASP Top 10, which is the top 10 vulnerabilities for web application security, is key. And there's also a serverless OWASP Top 10, which I really recommend looking into. It's still in quite an early stage, but it does have some key lessons that's very good to have a look at. Keep your team up to date with those OWASP Top 10, and try to use automated tools as much as possible. SNCC is a classic tool for dependency management, making sure you don't have insecure dependencies. It's not particular to serverless, but I'd recommend it really for any architecture. And Protego is a specialized provider in security automation for serverless applications. Account security, again, this isn't particular to serverless, but it's particular to cloud. And service has really made this more of an issue. As developers are empowered to have more and more access to deploy things into production, developers are getting more and more rights over our AWS accounts. I advise all our clients to split their AWS accounts by dev, staging, production, UAT, whichever environment you have, keep that separation. Not all developers need or necessarily want the responsibility of access to all production systems. And also they want to be careful about which ones they're using. You don't want to accidentally delete a database in production as opposed to dev. And if an access key is lost, you don't want that to affect production. Mainly we want access keys that are sort of being used more commonly, not to have that dangerous access. AWS organizations is a great way to consolidate billing when you have this sort of separation of AWS accounts. So previously, the CFO in your company would probably complain paying 4 invoices for different accounts. This consolidates all that billing, gives a little bit of observability across accounts, and also lets you share some IAM policies. And the final thing I want to touch on when it comes to account security is that MFA is never optional. So MFA for the console access, which I hope most of you have turned on, is a key. But MFA for command line access is also a key. A lot of us are deploying from the command line without MFA, which is a huge risk to your application. We had a client once who moved away from MFA protection on their CLI, and one of their junior developers accidentally posted their bash RC profile to a public GitHub repo in which they'd hard-coded their AWS secret key. Within about 5 minutes, a bot had scanned GitHub, found that, and tried to spin up large EC2 instances to mine cryptocurrency. Luckily, the AWS profile, the IAM policy prevented them from being able to use EC2, so serverless saved us there. But MFA is never optional on console or on command line. And you can easily enable this with a with an IAM policy. So you can add the condition Boolean if multi-factor authentication is present. And this is going to deny access to everything but those functionalities to set up MFA in the first place. This is a great safeguard, and you can do more advanced ones where you keep it valid for 15 minutes or 2 hours, whatever really works for your team. And basic command line scripts can automate a lot of this to make it a lot easier for your developers. The key thing here is to separate your accounts. This makes human error mitigated by quite a lot, and also can mitigate the risk of attacks and what the impact they can have. MFA is never optional for your teams. This applies to cloud computing, it also applies to email and many other services, but also on the command line, we need to make sure that we're not just using these secret keys that could be lost by human error or malicious activity. In conclusion to that, and there's a couple of things I want to talk about at the end of this talk, many things has changed with serverless, but some things haven't. So things like patching of the operating system have changed, but there are existing attack vectors we still need to be aware of, and there are new attack vectors, which mitigating them is key. Developer speed and autonomy is great. Serverless really empowers development teams to deliver to production and to deliver business value. But there is still a need for ops to coach developers on best practices and to automate as much as possible those best practice safeguards to prevent us from making mistakes that can cost our company money or can put our users' data at risk. As I mentioned earlier, I work for Theodo as VP of Engineering, and we run a couple of open source initiatives to try and share best practice about serverless. So we run a serverless transformation blog on Medium where we discuss things like Lambda security best practices, we have architectures and use cases, and feel free to have a look through that. We have a serverless newsletter which comes out about every 2 weeks with the top 5 articles from that week, touching on things like cloud security, but also about how serverless applications are changing and architectures are changing. And there's also a service transformation podcast where we discuss similar topics. Feel free to find that on Spotify, RSS feeds, and various other podcast places. And there's monthly panel discussions happening on our YouTube about serverless topics. There is one on security, I think there. Also on sort of how we can sort of help lower the barrier to entry to using serverless. If you've walked past our stand, you might have seen the serverless DevTools project we also have, which is open source. Now, this isn't a replacement for something like Epsagon, Thunder, or Lumigo. This is really like the cloud DevTools for the serverless world. It provides in-terminal feedback with simplified visibility and targeted metrics on your serverless application, and it looks like it's from the 1980s, which is quite cool. So you can see, you can run it, or you install it via npm, and then you can run it with a CloudFormation stack name. You can then see all your Lambda functions in the top right, and you can see, if you tab onto one of those, you can see the invocation history, the duration of that invocation, and updating CloudWatch logs. Now, it is all open source, so I look forward to seeing some pull requests, but if you do have any feedback, the issues are also there for you. Thanks, I've been Ben. I'm also very happy to announce I'm now an AWS Serverless Hero, so I'm hoping to produce a lot more content soon. One of those QR codes takes you to the blog, one of them takes you to the newsletter. I'm not sure which is which, so please subscribe to both. And yeah, thank you. If you have any questions, we have about 3 minutes.